This is a recycle talk that today that I gave to the during the MMN. So hopefully some of you have not heard this. So the title is talking about sustainability, and I know some of you probably remember we did one session on green labs uh, during one of, this year, and so but sustainability is a little bit broader than just green lab. So it's not just not only talking about present, also talking about the future. That so we more emphasize like four factors. Not only we talk about water conservation, energy conservation, and reducing waste. They also mention about resource management, which makes basically we want to use less resources and then also make our resources last much longer and causing less environmental harm. Okay, so a lot of these knowledges that I learned from one of the this is a big paper based on the reference is right here. So it's based on the case study from University of Groningen from Netherlands. So they follow some research labs and looking at their consumptions for I think for six months to a year. So what they found is so scientific research lab is actually very uh, it's not as earth friendly and they use a large quantity of energy and produce a lot of waste. So for instance, one single film would consume 3.5 times more energy than an average household. And they also found out the average annual CO2 consumption per person globally is 4.8 tons. In US, we have like twice the amount of the consumption to the other countries. And as a researcher, just work related CO2 consumption is 10 to 37 tons. That's not including our everyday consumption of our CO2 uh, carbon footprint. Okay, and laboratory research also produce a lot of plastic waste, and because we do use lots of single-use plastic. Okay, and that correspond to 2% of the global plastic waste. And the other thing they actually pointed out is when we attend conference, we actually generate a lot of CO2, emission, and because of the flying. And then they actually calculate if every research go to meetings, and we're going to use up so much energy and also produce a lot of carbon CO2 emission. So we do know a lot of times those things are unavoidable, okay, because we have to make sure our research is clean and well controlled. So a lot of time we have to use disposable plastic, okay. So so we are very resource intensive, but there are simple ways that we can make make our plastic consumption like minimize. Okay, so we're going to just talk about some simple things we can do. And so sustainable lab practice can significantly reduce the operation cost too. Okay, if we gradually start implementing some practice in our lab, and I think we can all make some difference and we can do more with less. I think that's especially relevant in this time and stage because I mean a lot of us have suffered budget cut and staff reduction. So I'm just going to go through what I have done for my lab. You know, I joined the FNL about 2 years ago. So we've just been my my staff, the number of staff is only 50% than what was before, and we also cut a lot of budget. So I have to look for ways. This is out of necessity to learn to how to stretch my lab resources and to do exactly the same amount of work, or actually even more. Okay, so I'm going to talk about what I have done and to figure out the ways we can do. Just giving us some ideas that we can do. It's not may not be good for everyone. Okay, so basically, when I try to evaluate the resources, my most valuable resources is my support staff, and their time is valuable because I don't have many of them. So I want to make sure that their work is most efficiency. I'm really using their time on the most valuable work and have the productive results using their time. Okay, so what I looked at is how I can streamline EM sample processing workflow. I'm not going to talk too much because Tom is going to have a more detailed discussion on that. And then so I evaluate some sample processing steps and trying to streamline and how I can maximize my staff time. Okay, so it's kind of a global thing. And we also, we talk about automation for 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 some time. There's quite a lot of instrument out there, and I will just give you some example how I use automated sample processing to help me to run the lab with less resources. So one of the things I did first is, when we used to have more staff, everybody take on one project. But when I have less project, we are forced to have teamwork. It's actually not a bad thing. So we did basically all of us are participating in similar project. We share the workload and we keep the workflow keep going. Okay, even someone has to go home early, and the other one will take it off, pick it up, and then keep the processing going. And so you can see we have a digital notebook, so all of us can enter it. So we are doing one project, but whoever does what step, all the lab steps are recorded in a database. And we also started to offer images to our users much earlier. Okay, so one of the things I realized is, we do say 100 projects a year, but we hardly see 5 publications. So I know 95% of our work are not at the final stage. A lot of them are intermediate project and intermediate data. So the user, they do not need perfect images. So some of time they will give us some samples and we process all the way to the end. Then they say, oh, everything failed. So what I did is I give them overview and preliminary images very quickly. Okay, so a lot of time, I would say probably 10, 20% of time, and they are happy with that. And so I don't have to keep going. And sometimes they would identify failed experiment right away and say, oh, Ru-ching, stop processing these. So sometimes they give me 20 samples. I said, tell me what is your priority. So I will do the first 5, and then they say, oh, the control didn't work. Just grab it. So we can actually become more productive and move things much faster. Even I'm not giving them the most beautiful EM images for them to publish. So we use a flexible protocol, not a fixed protocol. Every sample comes in, we try to see, okay, what's the best way to do it? Can we push it faster so we can finish earlier? Okay, so as I said, we use automated process at certain steps to follow to enhance the workflow. And we also allow users to come in to help us. So whenever they want to learn, which I really encourage all my users to learn EM, because I think knowledgeable users are better collaborators. So they will not demanding me to do something that's totally unrealistic. Okay, so the way we streamline EM sample processing, so we develop a rapid sample processor. So I think the idea behind that is when the time we use to process a 1 millimeter cube tissue should be different for when we are processing a monolayer cell, which are much thinner. Okay, so we have a rapid processing. We reduce all the staining and washing steps, and it works just perfectly. And then we can finish everything much faster instead of following a conventional processing. So sometimes we have very small pieces of tissue. We will also put them through the rapid processing. Okay, a few things are important that can help. One is vigorous shaking is critical for rapid processing. Shaking always helps. Whenever we can, we put everything on shaking. And dehydration, you can use ethanol compatible resin, then you don't have to go through acetone or propylene oxide. Okay, that also most of them are low viscosity resins, so that also speed up things. And along the way, we can include microwave, centrifugation, or vacuum. And Tom's going to go through that when he gives his talk. Okay. Um, so the other thing we kind of stop doing a lot of times is on-grid UA and LED staining. One thing that I like to point out is the digital imaging, digital camera and imaging. You can quickly adjust the contrast, which give you similar contrasting than UA and LED. So a lot of times I'll give user these and then they will quickly look and tell me if they want to contrast. Then I come back. ImageJ can do an auto contrast adjust. If you can even do a batch. Again, that saves us a lot of time than doing UA and LED on all the grids, and also reduce the number of grids that we need to prepare, because sometimes UA and LED tend to damage the grid. So there's various automated EM sample processor on the market. So no matter what you have, and one of the things I start to learn is they are not perfect. They cannot replace EM technology. So we don't have to worry about they're going to replace us, because they are still kind of limited for certain type of samples and size, and they all have pros and cons. Okay, so what I realize is I don't expect them to do everything. So, but I use their best the potentials and what's best, I use them. So one of the things robot is very good is liquid exchange. When we do immunogo, we do EM processing, a large quantity of our time is spent on changing liquid. We are washing. Okay, so these can be easily replaced by using the robot. Okay, so this drastically reduce the hands time for my staff, so we can do something else. So we spend some time doing the setup, and then we can come back, and we still take over some part that's difficult for the automation to do. Okay, so in the beginning, I was trying to develop a protocol using those automated instruments to complete everything. So finally, I realized this is not realistic. It's just taking me too much time, and they are not perfect. So I'll use what they can perform best for us. Okay. So we have automated processor protocol that can really help us quickly process things, but sometimes, we don't take it all the way down. We do the infiltration after the automation. We still do it by hand, but we have other methods to help us to enhance the speed for infiltration. Okay, so sometimes individual cells has to go through suspension cells that you need to do agarose enrobing, and we have also developed some way we can directly spin the cells in the processor sample holder, so we don't even have to do agarose enrobing. Okay, so one of the drawback of the instrument is there's also a little bit of carryover on the tips, and it's just not perfect. Sometimes there's tube has some solutions carry over outside, and sometimes there's a little bit of residual left in the wells. So of course you can keep improving. You can change tips at every steps, okay, for instance, or you can really just lower the tip to the maximum, trying to reduce the amount of residual. But it's not necessary, because I personally decided I don't want to use that much waste on the tips. So we know the liquid exchange in the automated platform is not perfect, but we do more washing steps to dilute off the residual left over, and you can do this in robot very easily. It's much easier, so we use that and to maximize the chances we can use robot to do the processing. So we have also managed to develop the post-embedded immunogold. So again, the robot is not perfect. So there's some steps I don't rely on the robot to do. For instance, the antibody step, we do pulse the instrument at the antibody, because I have limited volume of antibody. I do not like to add too much. So we use a pulsing step. So the automation is not fully automated. I call them semi-automated. But still, we were able to finish the labeling like in 4 to 5 hours. And then the total bench time required for us is just 30 minutes to 1 hour. So it is still work in progress. So this is one of the immunogold. I don't know if you can see because they are 6 nanometer gold, very small. We did try to do silver enhancement in the robot, and that did not work very well. So we are still trying to fine tune the process. Okay, so low viscosity resins. Okay, so there are a couple of low viscosity resin that we are actually trying keto 651 resin. And one of the reason I like the keto is actually compatible with alcohol, acetone, and also water. So it is reported to be compatible with immunohistochemistry. But I try to establish it, but I have not been very successful. But I did manage to do a immunogold. So this phase is embedded in ketol. And you can see there is some labeling, but not as intense as LR white. So I don't know if I need to go back to do etching. And again, if anybody has some other attempts that they can share, I would love to hear from them. Okay, but I think keto has a good potential because I know LRY works very well, but LRY does have to be embedded anaerobically. And so sometimes it may be difficult when you are doing the flat embedding. Okay, so the keto would be much easier if we can get it working. Again, I'm not sure if it's worth investing a lot of time. But so I'm going to talk about a little bit waste reduction. So that's also very critical for resource management. I think a lot of us do not realize the chemical waste collection and treatment are very expensive and carbon footprint is really high because a lot of the waste that collected have to be burned, incinerated. Okay, and all the chemical waste generated also have to be specially treated. Okay, so so for using the robot, we actually reduce the volume of osmium drastically than manual. So we also realize we can do this manually instead of using 1 mil. We have cut it down drastically to reduce the UA. And since Tom mentioned some labs reuse UA, so he'll probably discuss about how we can reduce the amount of UA used by reusing it. So we stopped using on-grid UA light, so we reduced more waste reduction. And some other labs have been trying to use alternative non-hazardous chemicals. For instance, we don't use cacodylate buffer in my lab anymore. We try to minimize the usage because everything has to be collected as a chemical waste. Okay, so in that, I'm going to give you two references at the end. So there are a publication on guideline for sustainable lab practice. They recommend us to consider a lot of less hazardous chemical that compatible and to replace them to make them more environmental friendly. Okay, so many of you are already using UA alternatives and the tip boxes, these are just simple things I think we can all do. And it's not that as painful to convert and to be more green and more earth friendly. Okay, so here is coming out from that reference talking about chemicals we can replace and they grade them, which ones are more environmental friendly, which one we try to avoid. So this is something you can probably go in to evaluate. So water conservation. Okay, so a lot of time we just go and use DI water, using whatever the purest water. But we never thought of sometimes, we never think maybe sometimes we don't really need the highest pure water because actually even we get the DI water, but treat those columns are very expensive. So again, you use the quality of the water that's really required to do your work. That can also help allow to conserve your resources. Okay. And so the other energy conservation, a big thing is maximize your instrument usage, okay, by sharing. Sharing resources is a big way. So for instance, where we are, NIH also has a huge surplus list. They constantly send us, say, look through the surplus list. If there's chemicals you can use or some other some small instrument or office supplies that you can pick from the surplus, and that will also save time and save money. Okay. And so the other thing is to close your film hood, the sash. Okay. So the I don't know if I have an article on that. So, but film hood is one of the biggest energy consumption in all our labs. I know EM lab we all have a film hood. I don't know if your film hood you can adjust the flow rate, but unfortunately the film hood in my lab has a fixed flow rate. But if you can close the sash at night or when you are not using your chemical hood, you can actually reduce a huge amount of energy consumption from your lab. Okay, here is a BioEMTalk laboratory survey, and I think some of you have seen this. Basically, really, what I want to point out in this slide is we are really far behind with a lot of labs in other countries. I mean, most of our schools are not implementing any sustainability practice. We do not get any information from the school, and they are not really helping us to be more green. Okay, I'm trying to make a difference where I am and trying to keep telling the my the management saying we should really think of how to conserve our resources, because I think it's much easier to push this practice from the institute-wide practice. Okay, and so one of the things I want to recommend you, as I said, when you want to push your institute to think of promoting sustainability, there are several keywords you can use is to tell them the long-term cost savings, enhance research efficiency, and increase reputation. Okay, the other thing I want to give you a little hint. When I come to my job here, I ask them to buy a robot automated processor. So of course it's going to cost them money. So what I tell them is, look, and you can save the salary and from one staff and accumulate time, and they actually save money. So they probably do not see the saving right away. So you need to recommend them to think of back financing. So basically you are using the money you're going to save from the future and come back to do the purchase, right now. So there's a lot of way to push for your institute to help you to make your lab greener. And so basically the biggest challenge is really a behavior. It's our habit. Okay, we are just so used to just grab a plastic tube or grab a bottle of water and not to think, we do not have to. If we just have a little mug, I take a little mug to go to seminars. I don't use the water bottle and things like that. So it's really a behavior change. It's especially true in our society. In the US, it's really built based on convenience and on the expense of our Earth's resources. So I hope that I'm bringing some awareness for you when you think that there's many ways that we can do, and there are a lot of initiatives to really help people to have green lab, and they have encouragement, they have award system, you can get certified. And I know some institute they will have a small competition. Any lab that saved more energy, they'll bring a pizza to your lab and things like that. So as I said, just really to encourage your colleagues and tell them the information of how much we are wasting, because it does not make sense. The biomedical research, we are really trying to help enhance human lives, but in the same time, we are actually generating a lot of waste using a lot of the resources for the future generation. Okay, so simple practice just by warming your freezer from -80 to -70, and which does not hurt the reagent that's stored in there, and you can save the consumption by 30%. Just very simple things like closing the sash, you can save a lot of energy too. Okay. All right. So I'm giving you these two references that they really form the foundation of sustainability practice in the lab. And I hope if you have time to go look through, and they did a case study as a really thorough study and analyzing things. Okay. And I'm going to stop here. And anybody has any questions? Or I can leave this here for you if you want to copy the references.